Okay, we're on Project N, still in Math 119, by the way. So let's talk about launching Sage again. I'm going to launch it. I'm going to launch it on a command line terminal application. Sage is opening and running now. And what I want to do is I want to talk about this particular project over here. And I got to be honest with you. Again, we're trying to get you guys to, read. I always say that a lot of people they actually major in STEM-related careers because they don't want to read. By the way, you're being deceived. By the way, STEM requires a tremendous amount of reading, and the reading is far more difficult to do than any other subject area, in my opinion. Now, what I mean by that, reading a novel, reading a page of a novel doesn't take that long, but reading a page of a mathematics textbook could take a lifetime. It really could. All right? So you have to start to realize if you want to get good at something, you're going to have to read. All right? So this one here is about the solving a cubic equation, and there's a formula for it. And the formula is no longer taught. And I think part of the reason for that is I'm not going to say it's complicated, but deriving it is not the easiest thing in the world. But deriving the quadratic formula is pretty damn easy. It really is. But I typed the code in, and this is about solving a cubic. All right, so let me reset in a generic way, by the way, given some coefficients. So reset, we've been doing this for some time, and now they define a bunch of variables. And the variables they're defining are x, a, b, c, d, e. A, B, C, D, E. Yep, var. I'm getting a little lazy. I want to do something here that I do recommend you do as well. I'm going to type this in, but I'm going to put it under one single quote. Whoops, I made a mistake. One single quote. Whoops. I'd have to quote each letter separately. So now X a variable, uppercase A, uppercase B, uppercase C, uppercase D, and uppercase E are all variables. Now what I want to do, I want to solve a cubic of the form x cubed plus bx plus c equals 0. All right? Now again, they mentioned an historic figure over here, Cardano. And Cardano is, he did a lot of work in mathematics. And one of the things he's really kind of like the discovery of a complex number, by the way. But anyway, let's just do our copy paste, right? We'll do this over here. And I want to claim it's not bad to do. I mean, you might be shocked by Sage's ability to do this. It's going to solve that equation, which is x cubed plus bx plus c for x. Just like you have the quadratic formula, but this is cubic. It's a depressed cubic, by the way. It's working on it. Oh, there it goes. I got to be honest with you. Looking at it, you might look at that and say, I have no idea what I'm looking at over here. Now, certainly what I could do, I'm going to do something that's not in your notes, by the way, underscore, which means the prior output. And what I want to do is, let me see. No, I'm not going to do that because it's on the notes. I don't want to confuse you guys. But you get this over here. You have the same output. It look kind of crazy looking. But here's the deal. What I want to do is I want to ask Sage to do the quadratic formula. So I'm gonna type it in solve. And when you took Math 100, they gave you a x squared, you notice I have to use the star, by the way, plus bx plus c is equal to 0. This is a generic form of a quadratic, and I want to solve for x. And you know the output of this because you did this by completing a square in Math 100, or at least your teacher should have done that. And you basically get the quadratic formula. Of course, they write it down two different ways because there is a plus or minus in it. Now, the cubic, if you notice, there's three separate ways. You'd expect that, by the way. You'd expect 3 solutions. Quadratic, you expect 2 solutions. And you learn that certainly in Math 119. All right? So let me point out, doing this one over here, more complicated. This is going to be a generic cubic. All right? I'm going to copy paste. I'm going to copy paste the whole line for you. All right. You notice no output came back out? Well, I'm going to type this. I hope you realize I put a semicolon there. Now, if I don't put the semicolon there, watch what happens now. It gives me all the output. All right? There's a difference. So if you don't want to see the output, put the semicolon there. All right? So what I'm going to do over here is, it's complicated. I'm not saying it's not. And I think this is part of the reason why a lot of students are no longer taught how to solve a cubic. All right. And the bottom line is, can Sage solve cubics? Yeah, it doesn't have a problem with it. You know, to do this thing very quickly, by the way. And I think you'd be in somewhat of awe of its ability to do that. The people that coded Sage certainly know their mathematics. There's no doubt about it. They know a lot of mathematics. We tend to really give you a very truncated version. And I think the reason for that is we're not expecting students to read books. If you're reading a book, though, you're going to be shocked how much information is packed into those books. Tremendous, especially in a mathematics book. I recommend you think about it, all right? Thank you so much for paying attention. Let me just take a look at the next thing up. Oh, there's another project. We'll have to get to that next. Give me a second.